Hi guys, we are students from IIT Delhi and we are building this project as a part of our MEP 101 course. The name of this project is Automatic Watering System. This project addresses a huge need of urban people. Now in urban cities, people are generally unable to water their plants because of time constraints, and they generally assign this job to a person, their house help or a gardener. And also when they are out of town or something like that, then no one can take care of their plants. Now we thought, why not automate this system? That is why we built this project. What this project does is that basically it gives out a regular supply of water at regular intervals of time. At the heart of this project lies this small chip, an 8 microcontroller. What this chip does is that it sends up signals of 5 volts magnitude after 15 seconds for 5 seconds duration. Those signals are then amplified by this motor driver. This motor driver in turn turns on a relay after 15 seconds or 5 seconds, and this relay turns on this bigger circuit of pump which is controlled by a wall socket supply. Now over to Kartikeya, who will be shedding light on other aspects of this project.
So guys, my name is Kartikeya and I'll tell you about the other aspects of our project. For our project, we made a water tank from acrylic sheets. The sheets have been joined together and made leak proof using chloroform, araldite and silicone gel. The tank consists of a hinge mechanism that can allow the user to access the pump and clean the tank as and when he desires. The tank also has a hole that matches the appropriate size of the pump outlet. The pipe outlet from the tank can be mounted with pipe dividers of different sizes so that plants having similar water needs can be catered to the same pump. If this project is to be upscaled, then a ball mechanism can be mounted to the tank, thereby maintaining a threshold level of water and eliminating the user's need to refill the tank again and again.
Hi guys, so now we'll see our project in action. As you can see, the main power source is turned on. So now I switch on my project, and for the first 5 seconds it gives out water and the pump is switched on. And now 5 seconds are over, so now the pump will remain switched off for 15 seconds. Now this time period can be adjusted for different plants with different water requirements, thereby minimizing losses like evaporation, because the plant will absorb only as much water as it requires. Now we can just wait, and now let's see, the 15 seconds time period is over and now it is again watering the plant for 5 seconds. Now it's again switched off. This process will continue.
So even though a lot of time was spent in discussion about the functioning, material and design and generally how to go about building the project, quite a few difficulties did crop up. Many of the things which we thought were theoretically possible turned out to be challenging to accomplish practically. So let us start with the box itself. We tried to build some aesthetics into the box by giving it a very different shape. A CAD model was initially prepared to determine the exact dimensions needed. The error limit we set for ourselves was approximately 2 millimeters, which comes out to be 1% in the dimensional error. It was a challenge to put the box together because it had to deal with liquids and have a capacity of 8 liters, which required it to be leak proof and also to be able to sustain a weight of the liquid. To assemble the walls of the block, chloroform was used. But even after using a syringe to apply the chloroform on the edges of the acrylic, there were spillages which resulted in some permanent marks on the container walls. Drilling the holes into the acrylic was also not easy because the thin sheet could crack under the pressure from the drill. A real challenge was slotting the hinge rod, and since it had to be made only halfway through the sheet, the hinges of required size were also not available, and we made our own hinge, which was something which we had not planned initially, but apparently it turned out pretty good. We also made our own water pump, which was powered by a battery, but eventually we found out it was not feasible, so had to resort to using an AC pump. Few other methods were suggested, like raising the platform raising the tank containing the water to a platform, but it also was not what we wanted to do. So eventually AC pump was the only solution possible. The pipe divider was made of sheet metal, and even the welded part has to be made waterproof by fixing it with M-seal. The discussions about how to open or close the water outlet was a long discussion in the group. When the project was initially thought of, it seemed pretty straightforward, but we encountered minor difficulties which made us aware of some commonly faced problems while designing a new product.
Hi guys, I'm back again. Now I'll be telling you about some unique aspects of this project. The best part of this project is its scalability. You can control more than 20 pumps using the same circuit. So thereby you can meet requirements of a large garden. Another unique aspect of this project is that we can link this project to your smartphone. We can make an app for that, so that you can control this project if you don't want it to go on automatic basis. Also, sensors can be made very easily, which will trigger the pump when the soil moisture falls below a certain level. Another unique aspect is that you can also add fertilizers to your plants. What you have to do is just dissolve those soluble fertilizers in the tank and it will distribute them accordingly. And the best part is, whether you are present in the house or you are out of the town, you can be assured that your plants are being taken care of well by this project. Thank you.
My name is Dhruv and I am going to tell you about how we came about fabricating this product. First, we made a tank out of acrylic, which we procured from junkyard. We use acrylic because it's light, non-corrosive and it's easy to handle. Acrylic pieces were cut using the circular saw, then they were sanded and filed, and finally joined using chloroform. The tank was made waterproof using silicone. Then we made a hole in the tank the size of the pump through which we could pull out the pipe. Then we also tried to make the pump, but it was unsuccessful. So for the time being we are using a ready-made pump. Then we made the flap for the tank using a simple hinge mechanism. Simultaneously, along with all of this, we are also making the electronic system. As an accessory, we made a pipe divider and finally we made a metal box for the breadboard. We made this project as a part of a product realization course. We are very thankful to the faculty members and the seniors who provided their guidance throughout the course. Also, please do like and hit the share button.